Hello, and welcome to the first lesson in Module 10, Polynomials. This is Lesson 10.1a, Adding Polynomials. Our objective for this lesson is that I can identify and write polynomials by using the standard form, and that I can add polynomials. So what are polynomials? Well, we've got a whole lot of vocabulary words we need to use for this lesson. So why don't we just get started right off the bat. A monomial is a number, a variable, or a product of a number and one or more variables. So this could look like 7. It could look like x. It could look like 3y, 2xy, 7x squared, right? These are all examples of monomials. It is one term of either numbers, variables, or the product of numbers and variables. A binomial. The prefix bi means two, so it is two monomials, and it is specifically the sum of two monomials. So this could be something like 3x plus 5. That's a binomial. 3x minus 2y. That's a binomial. Two terms added together or subtracted, which is just adding the opposite. Our next vocabulary word is a trinomial, which is the sum of three monomials. Tri is the prefix for 3, so this could be like 3x squared plus 5x minus 7. That is an example of a trinomial. 3 terms being added or subtracted together. A polynomial. Poly is a prefix meaning many, and so we have a sum of 2 or more monomials. So anything that's 2 or more is it's a monomial or the sum of 2 or more monomials. So a polynomial, all 3 of those specific categories count as a polynomial. All of them count as it. Okay, they are just specifically named ones based on their numbers of terms. But anything that is added or subtracted together, we can refer to as a polynomial. Now, when we're going to talk about the degree of a monomial, the degree is the sum of the exponents of all its variables. A non-zero constant has a degree of 0, and 0 itself has no degree. Okay, so a non-zero constant, something like 7 up above there, or the 3 on 3y, or the 2 and 2xy, or the 7 and 7x squared, those specific pieces would have degrees of 0. The numbers have a degree of 0. The degree of our polynomial is the greatest degree of any term in the polynomial. So you look at your greatest term. And now lastly, we come to our standard form. Terms are written in order from greatest degree to least degree. So highest exponents to lowest exponents. At this point, everything is expected to be written in standard form in order to get full credit. Everything must be in standard form to get full credit. Now, our next part here, the coefficient of the first term is called the leading coefficient. That is just that first coefficient, that first number on the term that has the highest degree. So it's the highest exponent. So let's take a look at example 1. We are going to find the degree of each monomial, and we're going to identify it. So when we look at letter A, we have variables and we have letters. None of the variables have an exponent shown, so I'm going to write it in to help us remember that each one of those has a variable or an exponent of 1. And so the degree of this monomial, the sum of the exponents of the variables is 2. So this is a second degree monomial. Letter B, we have negative 7y to the 4th z. So z is going to have that exponent of 1 on it. We add our exponents together. 4 plus 1 is 5. This is a 5th degree monomial. Letter C, we have 4x squared y to the fifth. 5 plus 2 is 7th. That is our 7th degree monomial. And again, the constants don't have a degree to them. So I would like you to pause the video and do letters D, E, and F on your own, and then come back and check your work against mine momentarily. Letter D, 4x to the fourth, y squared, z squared. So 4 plus 2 is 6, plus 2 is 8. This is an 8th degree monomial. Letter E, we have z to the third, y to the fifth. 5 plus 3 is 8th degree. And m to the fourth, n, when we add those together, 4 plus 1 is going to give us the 5th degree monomial. Now, we have, our next section is adding and subtracting monomials. And this is something that we have done over and over again. It came up in Module 2. It came up in Module 7 when we were dealing with exponents. The key to adding and subtracting monomials, you have to have the exact same variable factors and exponents. So the variables and the exponents have to match exactly in order for you to add and subtract them. So let's look at our first example. So in example A, we have negative 6x to the fourth plus 11x to the fourth. So our variable terms, they do in fact match. So we're able to add our two coefficients. So negative 6 plus 11 is 5x to the fourth. Letter B, we've got 2x squared y to the fourth minus 7x squared y to the fourth. So our variable factors, we check them, they are exactly the same. So we can do 2 minus 7, which is negative 5x squared y to the fourth. We'll fix that up so it looks better, and we can tell what it is, x squared y to the fourth. Letter C, we have 2c c to the third d squared plus 5c to the third d squared. Our variable terms are exactly the same, so we can add our coefficients together. 2 plus 5 gives me 7c to the third d squared. Now, I would like you to try D, E, and F on your own, then check your work against mine. So, letter D, we have 2x squared plus 7x squared. Our variable terms are exact, so we have 9x squared. Letter E, I have 3x squared minus 4x squared plus 6x squared y. So my variables here and here are exactly the same, but not my third term, right? We have x squared, and then x squared y. That is a different monomial, so we cannot combine those terms. They're not like terms. So 3x squared minus 4x squared, that's going to be negative x squared, and then we have plus 6x squared y. Nothing happens to it, it's just still tacked on at the end there. It's a separate term that we can't combine. Letter F, we have a longer string here. We have 6y squared plus 3x cubed minus y squared plus 5x squared. So we find our pieces that are common. So we have 6y squared minus y squared. That's going to give me 5y squared. We have a plus 3x squared, or 3x cubed. That's the only place x cubed shows up. So it just stays 3x cubed. And then we have plus 5x squared. Now, if you'll remember back, I said that all of our answers are expected now to be written in standard form. So we start with the term with the highest exponent, and that is 3x to the third. So we have that. We have 5y squared, and we have 5x squared. Now, those last two terms could be interchangeable. You could put them alphabetically and do 5x squared plus 5y squared. it really doesn't matter at that point. The degrees are what's important, and those two terms can be in either order. I chose to go with the order in which they were presented. You could choose to do alphabetical. That's up to you. All right. Now, when we're looking at some polynomials, we need to identify them in a couple of different ways. So first thing we're going to do is we're going to identify the degree of the polynomial. So we're starting with 6, and actually let's just have it zoomed out. Okay, so we're going to go with our degree for 6. 6 is a constant, so the degree is 0. I'll go back to the thicker pen for this. 0. The name using the degree is constant. There's no variable there. It's never going to change. There is only one term there, so that is a monomial. All right, now our next line, we have 5x plus 9. Our highest degree, our highest exponent is a 1, so that is the first degree. It does have a special name. We call first degree polynomials linear because they form a straight line. How many terms do we have here? We have 2 terms. Prefix of bi means 2, so that's a binomial. Okay. Next up, we have 4x squared plus 7x plus 3. Our highest exponent is a 2, so that is second degree. We call those quadratic. And we'll see those a lot more in this module and in our next module. We have 3 terms, so that's going to be a trinomial. Tri is the prefix for 3. All right, x cubed, now we're at third degree, and we call that a cubic because it's cubed. We're back to only one term, that's a monomial. Okay, now our next one, we have the fourth, 8x to the fourth minus 3x squared plus 5, so this is fourth degree, and that's a quartic. Quartic. There are 3 terms again, so that's trinomial. Okay. Our next one, we have 3x to the fifth minus 2x cubed minus 3x. So that's a fifth degree, and that's a quintic, Q-U-I-N-T-I-C, quintic. And that is 3 terms. It's a trinomial. And we're back to our last one now. X to the sixth minus 3x squared plus 3x plus 5. So this is sixth degree. And we don't have anything special at this point. So it is just called the nth degree. So in this case, it would be a 6th degree polynomial. There are 4 terms in this. And again, once we get over 3, we don't give it a special name. We just refer to it as polynomial. Okay, so it's just going to be a 6th degree polynomial. All right, now A and B, we want to write them in standard form for 1. We need to name it based on its degree and number of terms, and we need to identify what its leading coefficient is. So 2x minus 3 plus 8x squared. My first term is going to be the highest variable, so we have 8x squared. Next up is the 2x, so plus 2x, and then we have minus 3. So it is now 8x squared plus 2x minus 3. All we did, we used our associative properties, we rearranged things because they're being added. The order doesn't matter for adding in terms of the outcome, so we put them in standard form. Remember, the key to remember here is that your term, your sign in front of something is connected to it, okay? So the sign out in front is what's connected to it. That's why it's a minus 3 and a plus 2x, because those are positives. The minus 3 is a negative. So we got to keep that in mind. All right. We had a couple other things. We needed to name this. So this is a quadratic trinomial. And my leading coefficient for this one is going to be an 8, because that is the coefficient on my first term in standard form. All right, let's look at letter B. Our highest exponent here is plus 2x squared, so we have 2x squared, and then plus 6x is our next component. This is still quadratic, but it's a binomial. Bi, the prefix means 2. My leading coefficient is going to be a 2. My leading coefficient is 2. Okay. And now we're going to go to our 2 U-try problems. You're going to put those 4 U-try problems. You're going to put those in standard form. And then you're going to name them based on their composition. All right, letter C. We have our highest exponent is going to be negative 4x cubed. Our next exponents, well, squared, we have 2 of them, so we can combine those into 1. Negative 3x squared plus x squared is negative 2x squared. And then we have our constant of positive 2. So what is this? This is a cubic trinomial. Cubic because your first term, your exponent is 3. Our leading coefficient for this one is a negative 4. All right, letter D. A little bit longer of one, so we have to do a lot more kind of work with it. As I look at this, I notice that there's no other fifth terms here. So my first term stays 3x to the 5th. And then we have our next lowest term is x to the 4th. And then I have 2 terms with x to the 3rd in them. So I'm going to have negative 2x cubed plus 4x cubed. Negative 2 plus 4 is positive 2x cubed. And then at the end here, my last 3 terms, I have a squared, I have an x to the 1st, and I have no x term. Those are all going to stay exactly the same because there's nothing else for them to combine like terms with. So it's minus x squared plus x minus 4. So now I look at this. What is my highest term? My highest exponent is x to the 5th. So this is a quintic. And it's a polynomial because we are greater than 3 terms. And our leading coefficient for this one is going to be a 3. Letter E, we have 3x to the 4th minus 5x cubed plus x to the 7th. So x to the 7th, that's my first term. That's my highest exponent. Followed by, we have plus 3x to the 4th. And we have minus 5x cubed. So my name for this is going to be a 7th degree, and it's a trinomial. And my leading coefficient for this one is a 1, because remember, we have an imaginary 1 out in front when there is no coefficient. All right, letter F. Our highest exponent on this is x to the 11th. So we have x to the 11th. Plus, we have 3x to the 10th. Then we've got minus x to the 7th. minus x plus 13. So my name for this, 11th degree, and it's a polynomial. It's a polynomial. It is 5 terms to it, so it's just a polynomial. And again, my leading coefficient is going to be 1. So now we're going to go to the next page, and this is really the point of this entire module, which is adding polynomials. And so we are going to show you 2 methods. I don't care which method you choose to use. Either method is up to you, but we're going to show you how to do both of them, and we'll work some examples in both so you can see how that goes. So we have 6x plus 5y plus the quantity 5x minus 8y. So to do the vertical method, it's exactly how it sounds. We're going to list out our second piece directly below our first piece, and we are adding them together. We lined up our like terms so that we're adding like terms. So when I go ahead and add 6x plus 5x is 11x, and 5y plus negative 8y is negative 3y. And that's your simplified form. That's your added version. Why does this work? Again, associative property. Everything here is being added together, added or subtracted, so we can drop the parentheses and we can rearrange things. So that's the vertical method. There's also a horizontal method. So the horizontal method is where you are going to group things horizontally. So again, we drop the parentheses, right? So we can pretend they don't exist. So we'll just make them go away. And now we can rearrange things because now this is just an addition problem. So we have an x and we have plus 5x minus 7y plus 9y. So you group your terms that are common together and then you simplify. So x plus 5x is going to be 6x. Negative 7y plus 9y is plus 2y. All right, so now let's work through a couple of these examples and we'll see how this works. So letter A, we've got 2 trinomials being added together, 2x squared plus 3x minus 8, and that's being added to 3x squared plus 17 plus 4x. So the second one's not in standard form. We're going to work questions A and C. We're going to work this whole column in the vertical method. So the first things I do, we are adding. And so I put them where they belong. So we have 3x squared there. We have plus 4x there. And we have plus 17 there. And so now I add vertically. 2x squared plus 3x squared is 5x squared. 3x plus 4x is 7x. And negative 8 plus 17 is plus 9. And that's your final answer for letter A. Let's go ahead and do letter C right away because we're right here and we're going to use the same method. So we have 3x cubed plus 4x squared minus 5x plus 10 plus the quantity 9x cubed minus 6x squared plus 6. So we need to go ahead and write our terms. So we're adding. So we have 9x cubed. We have minus 6x squared. And we have a plus 6. And we're skipping over that 5x term for a reason. So 9x cubed plus 3x cubed, that's 12x cubed. And then we have 4x squared plus negative 6x squared, so that's minus 2x squared. There was no x term in our second trinomial, so it's still just going to be minus 5x. And plus 10 plus 6 is plus 16. All right, now let's do our 2 horizontal examples. So we've got negative 2x minus 3y plus negative 9y plus 4x. So again, we make it so that the brackets go away because now all we're doing is addition. And so we've got negative 2x, and we're going to group it with our other x term, which is plus 4x. And then we have minus 9y, or sorry, minus 3y, and then minus 9y. So we have those terms to combine now. We have our like terms. Negative 2x plus 4x is 2x. Negative 3y minus 9y is minus 12y. Letter D. Again, we're going to make our brackets go away because now we're just going to be adding like terms, and we're going to group things together by what they are. So we have 5x squared, and we have x squared, and we have 7y, and we have 9y. Combine like terms. X squared plus 5x squared is 6x squared. 7y plus 9y is plus 16y. Okay, so again, as you are working these, I don't have a preference for the method you are going to use. I have demonstrated examples of both methods for you. You choose the one that works best with your thought patterns and your brain patterns. I'm going to continue this pattern of the ones in the left column being the vertical examples and the ones in the right column being horizontal examples for you to see as we do our work on the You Try problems. But if you did it a different way, that's fine. You should see the same final answer that I have. All right. Letter E, we have 6x plus 5y plus 5x plus 8y. So we list that second one below the first. So we have 5x. We are adding 8y. We add them together. 5x plus 6x is 11x. 8 plus 5 is 13y. Okay, letter G, we'll do our two vertical examples at the same time. So we've got a 2x squared there, we've got a plus 4x there, and we have a plus 7 there. We're adding it all together. 42x squared plus 2x squared is 44x squared. We have 5x plus 4x is 9x, and negative 8 plus 7 is negative 1. All right, let's look at F and H. So the first thing we need to do is you don't actually have to be taking away the parentheses. If you know and understand what we're doing here, you can just write your next step. So you're going to group things by terms. So we have a 4x cubed. There's no other x cubed terms. We have the plus 7x squared. There's no other squared terms. Minus 2x plus 3x. And then we have a plus 4 and a plus 18. So the 4x cubed, nothing happens to it. 7x squared, nothing happens to it. Negative 2x plus 3x is plus x. And then plus 4 plus 18 is plus 22. All right. And our last example, letter H, we're going to do the same thing again. We're going to make our parentheses disappear. And then we are going to combine our terms. So 8x squared and 2x squared are going to be added together. Then we've got a plus 10x minus 14x minus 26 plus 18. Now we combine like terms. 8x squared plus 2x squared, that's 10x squared. 10x minus 4x, that's going to be minus 4x. And then negative 26 plus 18 is going to be minus 8. Now, when it comes to me, my personal preference would be to use the vertical method. That's just kind of how I visualize things better. I like to line things up vertically. That doesn't mean that any other method is lesser. I mean, they're both fine. My preference is to go with the vertical method. What your preference is whatever you are most comfortable with, what helps you visualize the math that's going together the best. All right, so that is the end of the Module 10.1a notes. If you have any questions, please bring them to class. Otherwise, I hope you have a great day.